Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at Pure Math 3 Transcendental Functions, Part 4 Trigonometry with a focus on the reciprocal functions and their sketches. So just a little bit of review here. We have our basic trigonometric functions. Of course, the most basic from the unit circle is sine and cosine. From sine and cosine, you can develop the entire trigonometric system. Those are the most fundamental, but we also include tangent when we're referring to the basic trigonometric functions. So again, these kind of relate to your Sekolah. Sine is opposite over adjacent or opposite over hypotenuse. So the opposite is usually the y-axis. Cosine is adjacent over hypotenuse, so usually it's talking about the x-axis. We try to use the x-axis as our point of reference. And tangent is opposite over adjacent, making it the y-axis over the x-axis, or sine over cosine. And it's also important to know that you can use tangent in relationship to slope when you get into trigonometry related to the algebra, because change in y over change in x. So these are the basic trig functions we looked at before. This formula here kind of ties together how to do trigonometric graphing. The A is the center line that your graph is basically connected to, the center line that helps you. The B is your amplitude above and below the center line. The positive or negative has to do with the direction. So this is the positive one. A negative one would go down and then up. On this one, this is the positive one. The negative one would start at the lower end of the amplitude and then go up and then back down. And over here, the negative would just simply go in the opposite direction as well. So that plus and minus has to do with the direction of your graph. Then you have your trigonometric function, which is either your sine, cosine, or tangent. The letter C is the number of cycles, how many times or how many complete cycles between 0 and 360, or between 0 and 2 pi. So the number of cycles. Then you have your variable, either x or theta. I try to use theta with degrees and x with radians. And then the letter D is called a phase shift. It shifts your graph left or right. So that one's a little bit more tricky, but we're going to focus on the reciprocal functions right now and the basic graph of the reciprocal functions. So instead of sine, cosine, and tangent, we're going to have the reciprocals. Now the reciprocal functions are cosecant, secant, and cotangent. And reciprocal in math basically means to just flip it upside down. So cosecant is the reciprocal of sine. So in other words, 1 over sine x. Cosecant x is the same as 1 over sine x. Secant x is the reciprocal of cosine. Secant x is the reciprocal of cosine. So it is 1 over cosine x. And cotangent is the reciprocal of tangent. You could write that in here if you wanted to. 1 over tan x. And usually you can also write it with respect to sine and cosine. It would be cosine x divided by sine x. So these are the reciprocal functions, and this is going to be important for you to remember when you get into the identities. Remember, the identities are kind of like equivalent statements that you can replace. So for example, you can replace tan x with sine x over cosine x. sine squared x plus cosine squared x equals 1. Those are the two identities that you learned back in Pure Maths 1. As we move forward into the part 5 video, we'll be getting into more identities that you'll be using in this Pure Maths 3 material. So knowing the reciprocal values in terms of sine and cosine will be helpful for you in the identities video. But for right now, we want to look at the graphing part, or introducing you to the reciprocal functions and then their graphs. So these are the three reciprocal: cosecant x, secant x, and cotan x, with their sine and cosine equivalents. Now for the graphing. The graphing is really not that difficult. Since you are reciprocating a basic function, the easiest way to do the graphs is to start with the basic function to begin with. So since cosecant is the reciprocal of sine, I've already put it a dotted line to represent the sine graph, just like up here, but in dotted lines. Now, the points that are the most helpful to you are the zeros and the ones. The zeros are the dots that are on your center line, in this case, the x-axis. So notice everywhere that there was a 0, I mark those. And then the ones. The ones are the dots that are at the high point and the low point of the amplitudes. Okay, so the zeros are the ones on the center line, and then the ones are the points at the top and bottom of the amplitudes. Now, why are those important? Well, let's start with the ones, that will make sense. If you have a 1 and you reciprocate it, you get 1 over 1, it's still 1. So when you reciprocate a 1, you get the same value. So that's going to become important, because the ones in the sine x graph are still going to be ones in the reciprocal graph. Okay, so that's one reason why we want to emphasize where the zeros and ones are at. Now, what about the zeros? Well, if you have a 0 on top, it's just 0. But if you reciprocate a 0, it means the 0 ends up in the denominator, and you can't divide by 0. So the zeros on the regular graph become vertical asymptotes on the reciprocal graph. Now, if you don't recognize the word asymptote, it's just kind of like an imaginary line that your graph can't go across. It's like a fence. The fence keeps you from crossing over it. So what we're going to do is, where the zeros are at, because we can't divide by 0, we're going to put an asymptote. It's like an invisible line. It's like a fence that will keep our graph from going over it. And our ones, when we reciprocate it, are still ones, meaning these 1 values, the 1 and the negative 1, are a part of our reciprocal graph. So now our graph will go from here up towards this fence, and up towards this fence, down towards this one, down towards that one. And so these solid lines here are the graph for y equals cosecant x. Now, of course, you need to pay attention to your center line, which in this case is an understood 0. We're at the x-axis. The amplitude, which is an understood 1, so that amplitude can expand. And also you need to pay attention to how many cycles that you need to put between 0 and 2 pi. So this here was marked out to 2 pi. And you also need to pay attention if it's shifted left or right, although I hope that they don't do that to you, especially with the reciprocal functions. But this A, B, and C especially, you need to pay attention closely to those. Now for the secant one, our zeros and ones are in a little bit different location, but we still mark the zeros of the graph where the original cosine graph was on the x-axis or on the our center line. And we also mark the ones, the top and bottom part of the amplitude. And so again, we cannot divide by zero. So we're going to get a vertical asymptote, our imaginary line, our fence line, through the zeros because we can't divide by zero. And when you reciprocate a 1, again, you get 1. So this will go up like this. This one will go down, down towards the fence, and this one goes up towards the fence like that. So here is a 0 to 2 pi graph, the solid lines of the secant function. Now when we get to y equals cotangent x, it's a little bit different because we don't have ones. When we had tangent, there is a 1 and a negative 1, but those weren't easy to see like the top and the bottom of the amplitude. So we'll just go with the zeros, and I've marked the zeros. They were at 0 and pi and 2 pi. So at 0, pi, and 2 pi, I mark the zeros. Again, when you reciprocate it, those become your asymptotes. And so when you reciprocate a 0, see here, these asymptotes, when they get reciprocated, they become 0. Zeros on the original become asymptotes in the reciprocal. Asymptotes in the reciprocal or in the original become zeros in the reciprocal. Can you follow that? So where there's a 0 in the original, the basic function, there will be an asymptote in the reciprocal function. Where there's an asymptote in the basic function, there will be zeros in our reciprocal function. Another thing to remember is that where tangent will go up, kind of like in a positive slope direction, your cotangent is going to go down. So it's going to start like this, and it's going to go down through this way, like that. So this one is a little bit more tricky. You got to remember to switch your direction. In fact, cotangent and a negative tangent are very similar, and the only way you can really tell them apart is from where the asymptotes are located. Because your negative tangent would go like this. Your negative tangent would go like this, and that looks the same thing like cotangent, but you can see that the asymptotes are located in a different place. So this one is definitely a little more challenging. I noticed that Cambridge tends to focus when it comes to graphing more on sine, cosine, secant, cosecant, although I have seen tangent used in graphing before. But this is basically what you need to do to learn the graphing. Now, the most important thing about this are the sine and cosine values for your identities. Every test will have identities with trigonometry on every test set. The graphing does not occur that often, but it is conceptually helpful for you to understand this formula. as well as being able to graph at least these four. Most sketching will involve these four. Again, they don't occur that often. In fact, I only have one example of sketching an invert or a reciprocal trigonometric function. So let me set that up for us and we'll look at one example in this video. Okay, let's look at our one example that we have here. I'll take you to the Cambridge question. Notice it comes from Winter 17 past paper 31. And the first part is actually an identity. Now, hopefully you remember from Pure Maths 1 that usually in the questions you start with an identity type problem and then it moves into a solving. Well, in this case, it starts with an identity and moves into a graphing. Now, we're not going to do the identity because we're video 5, part 5, will get into the identities. But if you remember from Pure Maths 1, we take this left-hand side using identities and we show that it becomes the right-hand side. So without doing the identity, we'll just assume that this tangent expression here becomes the secant expression on the right. So then the second part of the question says hence, meaning it's tied to this first part, graph, and it gives the tangent expression, and it has a domain from 0 to 90. So I'm going to put this 0 to 90 here on there, and it has the equal to on that. So from 0 to 90 is our domain statement. That's the section that they want graphed of this tangent expression. And of course, we don't really have to graph that. This hence connects us back to the 2 secant 2x. So this is really what we're going to graph here is the 2 secant 2x over the domain of 0 to 90. So coming to the board here, I've already written it down. I left our formula up here. So we have y equals 2 secant 2x. Remember, this is equivalent to that tangent expression. And so this one is the easier of the two to graph. Here's the domain statement from 0 to 90. And here is just reminding you the reciprocal equivalent of secant. Secant is the same thing as 1 over cosine. Now, what we want to look at is our formula parts. What is our center line? Well, our center line, we have no number out in front that's being added or subtracted to this trigonometric part. So that means our center line is at 0. So we have a center line at 0. And we have an amplitude. This positive 2 is the B part. That's the amplitude. So this goes up to 2 and down to negative 2. It goes 2 units both sides of the center line. This 2 is the C. That is your number of cycles. So between 0 and 2 pi, so this is pi here, and this is pi, 3 pi halves, and this one is pi halves. So between 0 and 2 pi, or actually we're in degrees here, so I put it in degrees. Normally I like to use theta for degrees, but they used x. So this is 360, this is 180, that makes this 270, and here is our 90 right here, which is going to come into play here. I don't worry about the domain until I've graphed what I'm used to graphing. Then you can go back and erase everything else except for your domain. So there need to be 2 cycles between 0 and 360, and it's a reciprocal of the cosine. So I'm just going to show a cosine graph, and I need to do 2 cycles. So it needs to start up here. It will go down to here, through this point and come up through this point and again right here. So that's one cycle. And then down through here, down to here, back up through here, and arrive back up here for the second cycle. So this kind of goes like this, down, up, there's one cycle, and then down again, like this, up. There's two cycles. So there's two cycles of cosine, and again, notice I have emphasized the zeros, and I've also emphasized what I call the ones. Now these are still ones because if you now do this, this is going to become 1/2, and 1/2 of 2 is still 1. You're still going to get these values, or actually, sorry, what you get, this is 1, and 1 times 2 is 2. So your ones, when you reciprocate it, still are ones, and then multiplied by your amplitude is still 2 or -2. Okay? So that's what this is. I still call them the ones. And so the zeros, when you flip them over, become asymptotes. In other words, our graph cannot cross these lines because we can't divide by 0. And then the ones are part of the graph that we want. So this one will go up here towards that. This one will go down like this, up like this, up like this, down, down, and up. That is what the graph would look like between 0 and 360, which is a normal domain. However, in this case, they only want the 0 to 90. So what they're looking for is this section right here, 0 to 90. That's the only thing you need. Here is your, whoops, I have 90 over here. So from 0 to 90, that is the part of the graph that they want. So that actually includes this down here, over and up. So this part and this part here are the two parts of this graph from 0 to 90. I just drew this over here so you can see your 2 and -2. It's actually the y-axis. This section right here is what you want. You could just erase the rest, but it's always helpful to use that cosine graph to help you graph the reciprocal. Then once you have in your mind where the graph is at, then you can make it fit the domain. So this one and this one, that is what you want for this graph type. It's kind of a short video. It's just on introducing you to the reciprocal functions and the sketch. And again, I only could find one example as far as the reciprocal functions go for graphing. You shouldn't run it into it too often, but especially if you're the student who's striving for the A star range, this is something that can make it or break it as far as that A star goes. So hope to again see you next time. Thank you for joining me in the Zoom room. Part 5 in the next video will be on the identities and the solving.